Welcome to the dOrg Hot Seat. This is the first episode of this series, and like the name suggests, it's all about the hard questions. The Hot Seat is a virtual seat, a place within the all hands meeting of the dOrg DAO, one of the most deeply technical DAOs out there. Guests sitting in the hot seat are key builders in the space, and they are given 10 minutes to explain their product, highlight a feature, or showcase a piece of technology they are proud of. After that, it's our builders' time to ask questions. Can we DAOify interviews, podcasts? Can we tap into the collective intelligence of dOrg? This series is the result. We hope you like it. And if you do, subscribe. Follow us on Twitter at dOrg_tech, and we'll have another chance to bring you innovative, decentralized content.
Well, hi everyone. My name's Jordan, and I'm here to talk to you about the Polywrap project. The whole goal of Polywrap is to better enable Web3 developer ecosystems. And so we'll talk a bit about how Polywrap achieves that. First off, here's our website, and then also here's a QR code for the slides. And so feel free to scan this and you can get the slides and check this out afterwards. And some prior knowledge that's good to have, but definitely not necessary. An understanding of software development in general, of the WebAssembly technology, and also some understanding of existing Web3 SDKs. This is all, good to have. And the goals of Polywrap, rather the goals of this presentation is to understand what is Polywrap, envision future use cases, as well as learn how to get started today. So first off, what is Polywrap? Polywrap can be summarized as trying to build a unified execution environment for the internet that is safe, open, and user-owned. With Polywrap, you can create these endlessly extensible pieces of software that can run anywhere. But what actually is Polywrap? Well, in short, we do this by creating a WebAssembly development framework that focuses on composability and also on-demand execution. And so the main motivation for doing all this comes from this hypothesis that Web3 has an integration problem. Web3 needs many modules in order to perform complex client-side logic. So this is logic that runs inside of your app. And this is different in Web3 than in Web2 because we don't have the luxury of private servers. And so when you're interacting with networks like IPFS and Ethereum, or using protocols on top of them, like let's say Uniswap, there's logic that has to be happening inside of your application before you actually issue that request to the Ethereum node or that request to the IPFS node. So all that logic typically is bundled into these SDKs, primarily in JavaScript. And so our thesis here is that these traditional modules, these JavaScript modules, are really holding software back. And this is because we've identified these 5 core problems. These SDKs are language specific, so you can only use it in JavaScript. You can't use it in another language like Go, let's say. They're also insecure by default, so they get added to your application directly. And so they can do whatever your application can do, which is not a good thing when you're including foreign code. These SDKs are not standardized, so composing them together is rather hard. They're also not upgradable because they get statically bundled into your app and they can't be upgraded. And then lastly, they bloat your application because they all get bundled into the same app. So you have a ceiling on how many integrations you can add to your Web3 application. And so Polywrap modules aim to solve all these. And I'll talk in more detail of how this actually works. But in summary, wrappers, these are the Polywrap modules that we call wrappers, are multi-language. They are secure by default, composable, upgradable, and allows you to create scalable applications. So how does WebAssembly is a very compact bytecode standard that is very easy to run your Go application, in your Rust, in your Python, in your JavaScript. So any type of language or platform you're running on, WebAssembly can run there. Also, WebAssembly is secure by default. So these little WebAssembly modules are actually sandboxed. So they cannot do everything that your application can do. So if your application has access to your private keys or to your file system, these WebAssembly modules cannot, unless you give them access to explicitly inside of your app. Also, another note on security is that this is a great platform for building capability-based security. So this is kind of the North Star for the whole WebAssembly ecosystem, is to implement capability-based security, which if you're familiar with is pretty cool, but I won't get into it. Also, wrappers are composable. So we build them with standard interfaces. These interfaces can be combined and composed and very, very easily, similar to combining and composing, let's say, Docker containers. They're upgradable. So these applications can pull down these wrappers at runtime. And so if there is a new version that gets published, your app can simply just go out and fetch it. And then now it has new code running inside of it. And this is actually pretty novel for applications. And they're actually scalable. So if your application has a upper threshold on memory usage, like let's say you can only use 200 megabytes of memory, you can garbage collect and basically remove the wrappers that aren't used anymore. So it only pulls down what's needed when it's needed, allowing your apps to stay lightweight. And so this actually allows you to create, theoretically like an infinitely scalable application with however many integrations you may need. But obviously in practical terms, that's not 100% practical. The developer experience is super simple. So the first step is just wrapping a protocol into a wrapper. So building a wrapper. And we built the Polywrap toolchain to make this extremely simple. The next step is deploying it. And you can deploy wrappers anywhere. But in this example, we're showing IPFS because we want to be as Web3 native as possible. And then lastly, you can integrate these into any application. So effectively, if you're looking for a summary of what we're trying to create here, I think that this is a good one. This is one that I personally like. We're building kind of like an internet operating system for in-application modules. And so if you're not familiar with the term internet operating system, it's what your browser is today. So when you visit a website, this is an internet operating system pulling down content, showing you a website, running JavaScript inside of it. And Polywrap allows you to do this with modules, so little modules of code. And so inside your website, you could have Polywrap running, and it could also be pulling down these secure modules of WebAssembly code at runtime. Kind of cool. We build in general, we focus on the developer experience first. We build extendable systems. So everything we build it with developer extendability in mind. So we don't make assumptions about what tech you want to use. You can use Polywrap with a full Web 2 tech stack. You can use it with a full local only tech stack with like the file system, or you can do full Web 3 with IPFS and Ethereum or whatever you want. So everything is customizable. And then lastly, we standardize along with adjacent technologies. So like we're building on top of existing standards like WebAssembly, and then we create our own standards when necessary. And so one of those standards we've created is called the WRAP standard. It stands for WebAssembly Random Access Protocol. The idea here is that we want to randomly be able to access WebAssembly modules. So we created a protocol around this. But I won't get into too much details, but the whole goal is for it to feel like magic. So Polywrap, using a Polywrap client, you can invoke or call any WebAssembly module. You simply provide its URI. So here we're providing an ENS domain that has a package at version 1.0, and inside of that wrapper there's a function called sum method, and we're providing these arguments. And so by simply pasting this into your app, you can now pull down this WebAssembly module and run this function. So just this kind of magic on-demand execution environment. Where do we fit into the broader ecosystem, if you were wondering? Our standard with WRAP lies on top of like WASM and the component model, and we sit kind of adjacent to the WASI standard, which is in very preliminary stages. And then as far as the runtime, the Polywrap client has a WebAssembly VM inside of it. All right, so now the fun stuff, like what are example use cases of Polywrap? I'm going to just kind of quickly go through these, but if any of these pique your interest, let's talk about it afterwards. Universal SDKs, so building an SDK that can run anywhere. Upgradable SDKs, so if you wanted to build, let's say, a smart contract protocol and have a SDK for it, you could store that SDK on, let's say, an ENS domain. And then if your DAO votes to upgrade your smart contract protocol, in that same transaction, you can upgrade your SDK. And so this actually allows you to create like on-demand upgradable SDKs that can kind of speed out updates to all of their integrators so that they don't have to rebuild their apps, which is really, really useful for smart contract protocols. Standard interfaces. So with wrappers, you can create standard interfaces. For example, like an automated market maker, or a bridge or a blockchain. And then based on these standard interfaces, you can create aggregators. So you can create aggregators. And the reason they're future-proof is because the source of the aggregation can be somewhere that's external to the app. So think of your app looking to a registry chain, and it can, pull down the latest set of implementations, and it can run those as it sees. So this allows your, Web3 aggregation applications like your portfolio viewers or your created on the fly on demand and be as like AWS Lambda. Polywrap makes building something like that very, very simple. And I'll show an example of that. Hybrid compute, being able to run things on the server and the client in a given workload. All right, and so we've been building for around 2 years. And releasing like our first kind of official version called Origin. And we've been kind of revving versions on top of that. And we're currently sitting at 0.9, 0.10 in the works, which support you can build wrappers in an example based on the tokens in your portfolio. It pulls down different wrappers to show their balances. So this allows you to basically integrate DeFi wrapper into your app. And then you can have the same functionality as, let's say, Zurion or Zapper by just including this one wrapper, and it'll get updated into the future. That's kind of the goal with it. Gelato off-chain resolvers is an example of node runtimes. So the Gelato project has a beta release of this out now. And these nodes, these Gelato nodes, run wrappers inside of them to perform off-chain logic. And so here's an example of it, this like scheduler. And if you look down here, this off-chain resolver hash, this is actually the IPFS hash of a wrapper. And so, if you look at this on wrappers.io, you can see what the WebAssembly looks like and see what the schema is and all that fun stuff. So, and then also wrap.link. So this is a fun project that Yuri had created, who's also a member of dOrg. And basically here with wrap.link, you can execute any wrapper. And so this is just a simple, fun example where we're executing the HTTP wrapper. And we're calling the get function. And the URL we're giving it is dOrg.tech. And so what we get back is an HTTP response. And in the body, this looks like HTML because it is. And so this is the HTML of the dOrg website. And so if we search for dOrg, we'll actually see the content of the website. dOrg's Web3 labs will bring your ideas to life. And this is all just through, giving this serverless runtime a link to a wrapper and a function to execute. So you can start building today. We have docs out there. You can check out all the awesome projects in the ecosystem, join our Discord, ask us questions. It's a very fun project, and happy hacking. Hopefully this allows you to create your Web3 dream applications.
Wow. You've mentioned a few times how they're future-proof and how these wrappers you don't need to change anything even if the upstream, whatever you're using, changes. But what happens if, let's say, IPFS does a breaking change and something changes in the way you do certain things around IPFS? Do you still need some sort of downstream integrator to actually wrap this new function, this new functionality, this new or this breaking change that you have created?
That's a great question. So if you have an IPFS wrapper and you want to include a breaking change in that, how can applications that include IPFS not be broken? Is that maybe the question?
That's absolutely, yeah.
Okay, cool. Yeah, so, this is where versioning comes into play. So the wrappers URI, we are creating a more standardized way, but, currently it's open to interpretation, but you can include a version there. And so similarly, how I was showing like domain.eth, at version.1.0.0. If I did, version at 1 and just left it as that, that's the major version. And so, if this wrapper was, conforming to semantic versioning standards, version 1 should never be broken, right? It should always just have the latest with no breaking changes made to the interface. And so that is just kind of a summary, I guess, like in the same way that when you include like an NPM module or a Rust crate, you specify a version and you can select whether you want patch upgrades, minor upgrades, or major upgrades. You can do that same thing with wrappers. But this doesn't protect against the case where the IPFS protocol itself introduces a completely breaking change. It's similar to like an Ethereum hard fork where, all Ethereum RPC applications are now broken. Like, that case cannot be protected against. But with these decentralized networks, that typically doesn't happen because they implement proper versioning semantics.
Excellent. Perfect. Yeah, thanks for that. So who takes care of the wrappers, and how do I, as a user of a particular wrapper, know that this wrapper is going to be updated at the same rate as the protocol that it's wrapping?
Yeah, that's a great question. Typically, you would want to use something that is maintained by the protocol itself. Similarly, just to kind of talk about an analogous situation, if I were to look on like crates.io for a Rust crate for, let's say, the Ethereum network, and I found one that is being maintained by some random person or team that I don't quite know who they are, and new versions haven't really been pushed to it in a couple months, I am not very confident about using this crate because it doesn't seem to be like a core priority of the Ethereum development team, let's say. So that same thing exists with wrappers. And what the Polywrap DAO is trying to do is it's trying to build this early, robust ecosystem of wrappers that we are trying to keep maintained with the ecosystems they serve. And so an example of this is we are working with the Gnosis Safe team to build a wrapper around the Gnosis Safe protocol. And they are personally interested in using Polywrap. And so maintaining this wrapper should be a core priority of theirs. And one way to increase the trust level of that for a consumer of this wrapper is to maybe host it at a Gnosis Safe owned ENS domain, so that way you can be sure that this safe is basically published by the organization or by the protocol, and it's being maintained by them. So levels of trust in what you integrate is kind of a complex thing, but this exists in every package ecosystem. And we're certainly trying to build tools and partnerships to make sure that this is an easy thing to navigate for developers in Polywrap.
Right on. Okay. How many of these is the Polywrap team maintaining versus how many are maintained by the protocols?
Awesome. Yeah, that's a great question. So I'm going to read off of this awesome Polywrap list, which, I'm sad this isn't public right now, but it will be probably once this goes live. Currently, the Polywrap DAO is maintaining an Ethereum RPC wrapper, so a wrapper to be able to interact with Ethereum nodes, as well as an ENS wrapper, an IPFS wrapper, and then a few other like system level ones, like for networking and file system and logging. But that's pretty much it for right now. And we've also built a few others that are standalone that really shouldn't change. Like, for example, a good example of an unchanging protocol is Uniswap and its V2 and V3. So we've built those wrappers and they shouldn't need to change at all. And then we're also helping sponsor the creation of the DeFi wrapper, but we're looking to other organizations to help build that as well and help maintain it. And then wrappers that are not maintained by us, the Safe DAO has sponsored the creation of the Safe wrapper. The XLR Bridge project has sponsored the creation of an XLR wrapper. And then also, I believe, different blockchains. Yeah, so Tezos, Near, and also Substrate, they've all sponsored the creation of wrappers. So Polywrap DAO obviously has an interest to help maintain those, but it's not the primary contributor, let's say.
Cool. Excellent.
I have a question. Now
Cool.
that I'm thinking.
Excellent.
Cool. So Jordan, you mentioned that eventually we want to support JavaScript in WebAssembly, right? So I have a question. If I understand things correctly, the purpose of AssemblyScript is it's to basically give you the experience of JavaScript, but being able to compile to WebAssembly. I was wondering, have you thought like how this will work? Like probably using another runtime, and does that make sense to you?
Yeah. Let's start with the JavaScript question. So how can you run JavaScript in WebAssembly? JavaScript is a interpreted language. It's a scripting language is like a common term, similar to like Python or like Lua. And so scripting languages need to be run inside of a runtime that supports it. And so you cannot basically compile JavaScript directly to WebAssembly. And so what we're planning on doing is we're planning on building a wrapper in WebAssembly that has a JavaScript runtime inside of it. And then you can then load that script into your wrapper and execute it. And there's lots of other WebAssembly projects that have done this as well to be able to execute JavaScript inside of the WebAssembly context. And so the reason for this is because there's just so many developers that are super familiar with JavaScript and they like using it, and so they want JavaScript support. And then your question about AssemblyScript and how that differs. AssemblyScript is not JavaScript. It's actually kind of like it tries to be similar to TypeScript mostly, and it compiles directly to WebAssembly. And so AssemblyScript is a great option for people that want a familiar syntax, but it doesn't have the benefit of all of the packages that exist in the JavaScript system. So a lot of stuff in AssemblyScript has to be built from scratch. And so having JavaScript support will allow you to tap into that huge ecosystem of JavaScript packages that exist today.
So a lot of the features listed as features of Polywrap are also features of WebAssembly in general, like secure by default and being able to run in any language or to be written in any language. So what are the main differentiating features between Polywrap and WebAssembly itself? What does Polywrap build on top of WebAssembly?
Yeah, that's a great question. So WebAssembly is a low-level standard that is hard to build on top of. So, for example, it today only supports sending integers across the WebAssembly boundary. So good luck, sending a complex data structure. Also, there's no kind of standard way of creating interfaces on top of your WebAssembly module. So knowing what code can be executed inside of it is hard. And the list goes on. Like the WebAssembly of today is just a very basic bytecode standard. And they're obviously working progressively to build new standards to make it more and more capable of more functionality. But Polywrap wants to build an easy developer experience on top of the WebAssembly core technology to allow developers to do these things as soon as possible. And so that's one way to look at it. That WebAssembly is rather slow moving, as it should be, because it's a fundamental standard. And Polywrap is pushing the boundary of what's possible with WebAssembly today. And then lastly, there are things that are in Polywrap's vision statement and what we are trying to do that are not on the radar or scope of the WebAssembly project as a whole. And so an example of this is, being able to create these future-proof aggregators, or being able to create these like on-the-fly dependency injection standards, being able to have a URI format to be able to easily identify these different modules on different hosting solutions. So yeah, there's lots of like higher order problems that Polywrap is solving to be able to address the needs of developers and the general development and also the Web3 space specifically. A way to think of this is like all of the web development frameworks that were built on base HTML, and the base HTML standard kept iterating and evolving little by little, slowly adding, like, let's say the concept of web components. But things like React had already existed for a while, which kind of like pushed developers and allowed them to create these like component-based applications. So that's a good way I think of thinking about the complementary doings of WebAssembly and Polywrap.
Thank you.
I was just wondering, when can I use the Polywrap to execute WASM modules in the MetaMask snap that me and Niraj plan to build at India this weekend?
Yeah, I actually I'm kicking myself because I planned on putting that in the slides, but I forgot to this morning. But yeah, Chris, who was just talking, and also Niraj are in India Hackathon, and they're planning on adding Polywrap support to MetaMask. So you can add a snap, which is what MetaMask calls their like little applications that run inside of MetaMask, and they're adding Polywrap there. And so maybe and an example of this is you could take the wrap.link that I was showing earlier, and you could run that in your MetaMask, or maybe do something more interesting like do a swap on Uniswap by simply pasting a wrap link that calls the Uniswap wrapper, and execute that trade inside of your MetaMask. So like really cool stuff can be done, but I'm not sure Chris would know more of how that is going than I.
Wow, looking forward to see this snap. Awesome.
Yeah, I had another question. Is it being tested in real life conditions, like with real users, real transactions, and in the case of the nodes, like the gelato case? How many nodes does an application need to run in order to have like a healthy network?
Yeah, sure. So for the first question, I've created a application on top of the Uniswap wrappers, because that was one of our first ways in which we kind of kicked the tires on the whole thing. And you're able to use that application today if you wanted, and it sends transactions to any network you would like to transact with. So that's kind of just like one example. But the project is still early. So if people are looking to use this in production for real, please get in contact with us. We'll work with you to make that happen in a responsible way. So I would say that the project is still under development. We're getting close to stamping it production ready, but that's happening gradually with the different integrations we're working with. And then as far as like how many nodes should Gelato be running to have a resilient network, I think was the question. Yeah, I'm not sure. The whole node network stack is something that different projects tackle for themselves, and that's out of scope for the Polywrap project. We just provide the runtime for these nodes. That would be up to Gelato to figure out how they want to build their resilient network.
Awesome. Thank you. And thanks for the disclaimer.
Yeah, for sure.
All right. So with that, we have reached the end of the dOrg hot seat for today.